Here's a quick video with a demo of problem 5 in MyLab homework for section 11.3. I've skipped ahead to part C, but basically we're asked to test whether the mean number of runs scored in a League A park is greater than the mean number of runs scored in a League B park. And they've prescribed 0.01 as the level of significance. So in this case, the null hypothesis, we're in the scenario of 11.3, which is an independent sample scenario. In the textbook, it shows up on page 548, and they give you the three possibilities for the test types. Your null hypothesis is always the boundary of the alternative hypothesis, which is to say the null is that the two means are equal. And then the question is whether we're looking at a one-tailed test or a two-tailed test. And so in this case, we're asked whether the mean for League A is greater than the mean for League B. That's a one-tailed test. So I'm going to go ahead and enter in the null that the two are equal. And then the alternative is that A is greater than B. And so that gives me a setup for the test. Now I'm asked to find the test statistic. What I'm going to do is pull up StatCrunch and let StatCrunch do all the work for me in this case, rather than using Excel. But what I'm getting is that League A is in column A and the League B games are in column B. So I'm going to go through. It just so happens that the two sets have the same sample size. That's not a requirement in this type of test. In the matched pair test that we did in 11.2, it is, because each row is actually a pair, like fathers and sons in the last video. In this case, the two samples are independent. So I'm going to go through and do t-stats. To sample, so not paired, but to sample with data. And it's t-stats instead of z because we don't know the population standard deviations, and this is what we need to use instead. This model reflects sampling distribution more accurately. So the first sample is A with a designated hitter. Second is B without a designated hitter. And we're doing a hypothesis test. Now, we just went through the setup of these hypotheses, but the alternative is that A is greater than B. So I want to say that that's the same thing as A minus B is greater than 0. And that's the way they've set this up for StatCrunch. So I'm going to pull p-values and summary statistics into this output, and this is what I get. So it's telling me I'm doing a test for the difference in means. It's giving me the difference in the sample means, which is just the difference between that mean and that mean. And it's telling me degrees of freedom. There's a formula for that. And standard error, there's a formula for that. Those are part of the model itself. And then it gives me the test statistic, in this case the t-value, and the p-value. So I'm going to go through, grab this test stat because that's what they're asking me for now, and I want to round it to 2 decimal places. So it's 2.178, so 2.18. And then it's asking me for the p-value, so I'm going to grab that. And they want 3 decimal places, so I'm going to go 0.017. Okay, and now it's a matter of interpreting this. Well, the p-value is a measure of how likely the observation observed in this sample is, assuming the null hypothesis is true. In this case, that likelihood that we observe 2 sample means at least this difference, with this difference, in other words, at least with a difference of 1.7666, is 1.7%. And that's relatively small. The real question is, how does it compare to the prescribed level of significance? In this case, they drove that level of significance way down. So this alpha value is the threshold that we use to assess the p-value. Since the p-value is greater than alpha, we conclude that the way this test is set up, this sample does not provide significant evidence in favor of the alternative hypothesis. So if the p-value is greater than alpha, the evidence is not significant in favor of the alternative, therefore we fail to reject the null. If, on the other hand, the p-value were less than alpha, we would say this is indeed significant evidence in favor of the alternative, and therefore we reject the null. So our case, 1.7% for the p-value, but 1% for the alpha. So we do not reject H0 because there is not sufficient evidence. And, in this case, they're asking us for a 99% confidence interval. We could do this manually, but back in StatCrunch, in that same output, we were able to do a confidence interval, and they asked us for the 99% level. So they give me lower limit, and they want this at, there was a negative sign that my copying did not pick up, and they want to round to 3 decimal places, so 400, and the upper bound, here it says upper limit, here it says upper bound, those are really the same. Again, 3 decimal places, 0.933. And that's my confidence interval. They're asking us to interpret the confidence interval, and in this case, it's a 99% confidence interval, so we're 99% confident that the difference between the mean number of runs scored in a League A park and the mean number of runs scored in a League B park is between this value and this value. So we could type those in these boxes. Then the question is whether the confidence interval contains 0. In this case it does, since the lower bound is negative and the upper is positive. And so that means that given this sample, we can't say that there's significant evidence that these two means are different, right? Because at this level of confidence, 0, in other words, the point at which the two means are equal, 0 was contained in the interval. And so the conclusion through the confidence interval approach is the same as the conclusion through the p-value approach. They always should be. And they probably want 3 decimal places. Oh, my typing is over. Okay.